So how was the day today? Divya, Tarur Divya.
It was all right. How was yours?
I'm also very tired today. Lot of classes from morning to evening. You people have combined, so I'm having what is that? 140 minutes, 2 hours gap. Otherwise, total day in class. So what topic is going on in 4425?
HPLC.
Hmm?
HPLC.
HPL.
Testing of compounds.
Hmm. 1 second. In Japan already na class ఉన్నది. Okay. So last class we were discussing about alkylating agents, anti-cancer drugs. We classified. Then we have seen alkylating agents. Then we have seen its mechanism of action. Mm, mechanism of action. Then we have seen some of the drugs. If they're attached to aromatic ring and some carboxylic group, activity has improved. And some more we have seen uh, uh, we this is one more drug, melphalan, where phenylalanine is attached amino acid. Nowadays, no, if a drug is active, they would like to combine, especially if the drugs are targeting nucleic acids, RNA, DNA, then they usually they usually combine with amino acids. So DNA, RNA are formed with the combination of amino acids. So they are better observed, better results are obtained. Most of the drugs, a lot of research is going on where amino acid sequence will be attached. One such example, and it was successful, is melphalan. Melphalan, where phenylalanine was attached. It was successful. Then we left here, up to here. Cyclophosphamide. Cyclophosphamide. Now, the trade name for this is cytotaxan. Cytotaxone. Now, you see, it is 132 azaphosphorine derivative. It is a heterocyclic ring where oxygen, phosphorus, nitrogen is present. If you can recollect, when there is multiple heteroatoms, the sequence of numbering is like this: oxygen, OS, NP, OS, NP, oxygen, sulfur, nitrogen, phosphorus. We learned the reason and everything. So number 1 is given to oxygen. Number 2 is automatically to the next atom. You can give number to the carbon as well as phosphorus. But the preference is given to phosphorus because then carbon, phosphorus is heteroatom. So number 2, then number 3. So 1, 3. We are telling 3. 1, 3 azaphosphorine. 1, 3. First is oxygen. Next number 3. Number 3 is Aza. Number 2 is phosphorine. So this is the way we represent this cyclophosphamide. It is most commonly used alkylating agent among all these. Broad applications. Broad application. It is a prodrug. It's a prodrug and is not toxic itself. It's a prodrug and it is not toxic itself. So previous drugs are, they themselves are becoming toxic. So here, if metabolism occurring, then only toxicity you are getting. Let us see. That is a beautiful mechanism. In next slide, you can see it. What is the chemical constant is responsible for toxicity and which part? What is the drug counter for this cyclophosphamide? We will learn. So it is a prodrug and it is not toxic itself. Then usually given by oral, IV, IM. So this is also better compliance to the patient. So whichever route you require, you can give. Activation takes place by cytochrome P450 monooxygenase. This is the enzyme. Cytochrome P450 monooxygenase in the liver to form phosphoramide mustard. So what happens is that this drug will get metabolized in sequence of events and you get phosphoramide mustard. We will see that how does this is formed. And there is another chemical formed as acrolein. This is responsible for toxicity. Let us see this activation process, then we will come to uses. Well, I hope you people are following. So this hectic day, last period, please try to concentrate. Now, now you see, this is cyclophosphamide. So we reversed it just for our convenience process. So in the previous slide, we learned that cyclophosphamide is metabolized by cytochrome P450 enzyme monooxidase. So what happens is that you get hydroxyl group at the 4th position. The 4th position, that is next to the nitrogen, you get hydroxyl group. Then this is hydroxycyclophosphamide. Then when the hydroxyl group is formed, what happens is that ring opening is occurring. Ring opening is occurring. So what happened? The lone pair present in oxygen. Lone pair present in oxygen will be donated between oxygen and 4th carbon. So there is formation of double bond. Valence at this carbon increases, so there is break. It breaks the bond. Then the proton released from here will attach to amine group, to the NH group, to form NH2 group. Now you observe carefully. This is 4th carbon. This is 4th carbon. Here also this is 4th carbon. 4th carbon has converted to keto group. Sorry, aldehyde. Why we are telling aldehyde? Because of presence of hydrogen. So you are getting aldehyde functional group. And we have exposed hydrogen. Which hydrogen? It is 5th one. So, so this carbon. So just for a convenience sake, we have altered the structure. Now, so we expose the hydrogen. Now this hydrogen there is formation of double bond between fifth and sixth carbon. There is formation of double bond between sixth and fifth carbon. Now you can see when there is formation of double bond, what happened here? Again, valency increases. So there is breakage. There is breakage. When it breaks, no, the newly formed compound H C double bond O CH double bond CH2. This is called as acrolein. This is called as acrolein. You must remember that the alkyl groups which were donated dichloro bis dichloro ethylamine ethyl group, we have converted to R2, just simple like R2. Simple, we have converted to R or R2. Now on breaking, no, we are exposing that. Now this is phosphoramide mustard. Phosphoramide, you see, phosphate group is present and mustard group is present, that is bis dichloroalkylamine. So now this molecule is active molecule. This molecule is active molecule. This will show anti-cancer activity. This will show anti-cancer activity. So now you see, that's what we have written. Now the active phosphoramide mustard reacts with nucleophiles. Nucleophiles. Again the same principle. Removal of chlorine, loss of chlorine, formation of aziridine. Again binding to the nucleophile, one strand, again this strand, same story repeats or same mechanism repeats again and binds to it, binds to DNA. So any doubt here, students? Please.
No doubt, sir.
No doubt. So please try to, I don't know how many people are taking lecture notes. If you take lecture notes, it will be interesting. Otherwise, this is odd hours. It will be very boring. So if I write, if I ask, write the mechanism of action of cyclophosphamide, do not end up to here. This is only activation step. Activation step. You need to write further. You need to write further. If it is open book exam, you need to write all these structures. Be ready. There may be chance of open book exam like that. Sorry, open book not. Exams may be conducted face to face. They're telling, I don't know. Be ready for that. So this is the activation process. Once this phosphoramide mustard is formed, then as a formation of aziridine, binding to nucleophile, then again another bis, no, another diethyl chloride, chloroethyl group, there is formation of aziridine, it binds to the another strand. After that, what happened? Miscoding occurs, breaking of indole ring, indole ring in a guanidine molecule, it occurs. Then whatever we have seen in the principle, in the mechanism of action, same thing will repeat again. Will repeat again. Now, note. See, what are the important points? Cyclophosphamide is most commonly used alkylating agent. Non-toxic prodrug, orally active. Acrolein is associated with toxicity. This is associated with toxicity. It causes kidney damage. Let us see what, how does it damage and everything. And what drug it we give. Now, the released acrolein released causes kidney toxicity. How acrolein produced is electrophilic in nature. electrophilic in nature, and it can react with kidney and bladder. So it has tendency. We don't know what's the reason. Acrolein is produced in our body, intestine, or in the liver it is produced, but it is going and concentrating on the kidney and the bladder. So that's why we are getting toxicity, kidney toxicity. How to overcome this? There is one drug called as Mesna. Mesna. What is the name? Mesna, trade name. This is Mesna. The chemical name is 2-mercapto. 2-mercapto. 1, 2. 2-mercapto. Ethane. See, ethane. Sulfonate sodium. Sulfonate. This is sulfonate group. Sulfonate sodium. What happens is that this drug will react with acrolein. Will react with acrolein to form an addict product. Addict product. What happens is that here you see double bond is there. Double bond. The lone pair here, the double bond, let us show like this. It will be placed between sulfur and this carbon. So now when it binds to this molecule, what is this molecule? 2-mercapto sodium sulfonate. Sulfonate sodium. When it binds, you get a adduct product. You see CH2 single bond, CH2 aldehyde. Adduct form. Now this is easily excretable now. It is easily excretable because of sodium salts. Because of sodium salts. This is SO3. Don't consider the 3 sodium molecules. It is SO3. It is SO3. This is also CH2. So you need to keep in mind this. Something I didn't put superscript, subscript. Subscript I didn't place that. This addition product. Addition, why I am telling, double bond are converted to saturated compounds. Double bonds are converted to saturated compounds. So you get addition products. And this we can be excreted or eliminated by urine. So if you combination of drug, as soon as now we know that what is the side effect of cyclophosphamide. So it is common, every patient you will get this kidney toxicity. So what you need to do, as soon as you start administering this cyclophosphamide, you need to take Mesna. So the kidney damage, intensity of kidney damage will be subsided. This has to be kept in mind. So it is combination drugs. So in cancer, no, not only for the treatment, you give a good meal of tablets, good meal of medications. Otherwise, no, the associated side effects will kill the patient. We have learned first day itself. What is the problem in the treatment of cancer is that it is easy to kill cancer. But what is the challenging? It is the challenging is one, patient has to get survive. We are successful in the laboratory, but not in the in vivo. So please, as soon as you give, if you see a prescription with cyclophosphamide, but not Mesna, you need to warn your doctor, telling that please prescribe Mesna with valid reason, so that he may forget, so that he may again prescribe this drug. So this is, please sign for your attendance. Only 24 people have signed. Remaining 20 people, what happened? Now, how do we synthesize? Now we are learning the synthesis of cyclophosphamide. The first thing is that we need to take bis dichloroethylamine. ethylamine, bis dichloro, bis dichloroethylamine, and treated with phosphorus oxychloride, phosphorus oxychloride, with the loss of hydrochloric acid in presence of base, what happens is that this hydrogen and one chlorine with the loss of hydrochloric acid, now this phosphorus oxychloride will attach to this dichloroethylamine to form a compound like this. To form a compound. You see, this molecule is like phosphoramide mustard. Only OH group has to be present. OH and NH2 group has to be present. Now treat this molecule with amino ethanol. 1, 2, 3. Amino 3 amino propanol. What happens is that there is a ring closure formation here. There is ring closure formation with the loss of hydrochloric acid. With the loss of hydrochloric acid, 2 hydrochloric acid it forms. There is loss. And you get a cyclophosphamide. No, this is very important drug. Now, bis 2-chloroethyl group is essential for activity. Monochloroethyl group, if it is present, we have already learned activity will be less. If it is bis, no, it is more active. Replacement of halogen, chlorine, no, with other halogens decreases activity. The best one is chlorine. Then levo form is active here. Levo form is active. Levo form is active. This is regarding cyclophosphamide. Then coming to uses, it is used, you see, in various diseases, Hodgkin's diseases, other lymphomas, breast cancer, lung cancer. It is also used as immunosuppressant. In transplant rejection. It is also used in rheumatoid arthritis. Other than cancer, we can use as immunosuppressant drug. So this is regarding cyclophosphamide. Any doubt, please? You can see the mechanism. See, previously I didn't place it numbering, so it makes you little confusion. So it was the ring like this. So how does this hydrogen come, or how this keto group is formed at this place? Now the numbering will help you where the bond breakage and everything is occurring and how it is formed. You check. Now one more. You can see it. I told you amino acids. Amino acids are combined. Now you see here. This is also one more beautiful concept. You can see it. Estramustine. So nitrogen mustard. Nitrogen mustard are combined to estradiol. So this is estrogen. This is estrogen. So it's a component of our body. Huh? Both males and females, you get estrogens. Huh? Uh, both male and females also generate estrogens. So estrogens are converted to testosterone. In everyone, no, estrogens are converted to testosterone. I know you people know all this. Suppose, huh? In females, what happens? No, it stops up to here. It stops up to here. Estrogen is not converted to testosterone, but in male, no, estrogens are converted to testosterone. Estrogen means estration process, urge to sex. This is the hormone which is responsible for urge to sex. Now, if you combine here estramustine. Now, this drug, you see here in I was telling these are, what is that? Hormone therapy. Hormones are used in cancer treatment in something around 70, something like that. What they do is that they give opposite hormones for treat. For example, breast cancer, you can give testosterone. For prostate cancer, you can give estrogen. Opposite sex will be given. Opposite hormones will be given to subside the cancer. So estramustine is given for the treatment of prostate cancer. We have learned some of the drugs in alpha 1 receptor agonist last semester. That drugs also can be used in prostate cancer. Prostate cancer is a benign cancer. We learned in the first class. You refer that. It is only issue is the urination problem. Issue is urination problem. Now, you see, this is estradiol. Suppose if this is OH is present. Now, estradiol. Two hydroxyl groups are present. So, estradiol. So, here what happens is that, it is combined with an ester group. With a ester group. This is called as urethane group. Urethane group. We learned many times urethane carbamate. This is more stronger than ester group. So urethane group is electron withdrawing group. Electron withdrawing group. So lowers nucleophile strength of nitrogen. Electron withdrawing group. So this group is there, no, carbonyl group withdraws electrons. So lowers, what is that, nucleophilic character. So there is slow formation of aziridine and it can act slowly. This is the advantage of estramustine. Now, alkylating group is attached to estradiol. Steroid is hydrophobic. Because of this, it can cross the it can cross the cell membrane, especially in the prostate cancer, and show its action effectively. So I told you first itself during the class. Now that strategy is that they want to combine a food material, a food component with the drug. So, so what happens is that they will be better absorbed. So estradiol is a normal component of our body, so it can absorb well. This is estramustine. This is, you see. Now one more, uracil mustard. So uracil is a cytosine derivative. So it is what is it? Adenine purines. It's our RNA component. So now again, see here also this is electron rich. Uracil is having electron withdrawing groups. You see carbonyl group, nitrogens, and again carbonyl group. All these withdraws lone pair of electrons present on nitrogen, like aromatic ring. Now here also you can see it, and whenever this mustard group is attached to aromatic ring, what happens? Uh, uh, Toxicity decreased, we learned in third slide or fourth slide. Same way here also decreased. So less reactive alkylating agents. But what is important thing is that it mimics nucleic acid bases. Here also it mimics like hormone, but here it mimics like nucleic acid bases. Concentrated in fast growing cells. This drug will concentrate in fast growing cell. Then uracil mustard selectively inhibit the synthesis of deoxyribonucleic acid. Ribonucleic acid. Then it is used in lymphatic malignancies such as non-Hodgkin's lymphomas. If you really want, you need to learn what do you mean by non-Hodgkin's disease, pathology. I think you people might have learned in cancer. Or just revise them. I didn't learn. My way of teaching, no, in India, no, mostly it is towards industry. We don't read more about physiology, anatomy, maximum 1 year. Clinical pharmacy also we read only in 1 semester. That is also 4 months we learned. Whatever I learned is my experience or something. Please, as you are patient oriented, please go through that. It will help you. It will help you. Suppose in India, if you want to learn, like we need to do Pharma D. One more course is there, Pharma D. That is patient oriented. It is 6 years course. It is patient oriented. B Farm is like industry oriented. It's 4 years. 4 years course. So please learn. If you want, you can learn what do you mean by Atkins disease, lymphatic malignancy. Huge topic. Now, nitrosoureas. So till now, what we learned? Only nitrogen mustard. Now we want to learn nitrosoureas. This can be done very faster because we have done all the homework. So let us see. Here, carmustine, lomustine, streptozocin. These are the 3 drugs used in treatment of cancer under the heading nitrosoureas. Nitro group. Nitroso. This is nitroso. And this is urea. NH2, C double bond O, NH2, urea. So that's why they are called as nitrosoureas. Again, you can see bifunctional group, ethylamine, chloroethylamine group. Same way like that. It is called carmustine. Now, let me see it. Now you see bis 1,3 we given numbering to the urea. 1. Why we given to this nitrogen? There is alkyl group. This is also alkyl group is there. 1 and 2nd. But there is extra functional group here, nitro. That's why we have given 1. 1. 1, 3. Bis. 2 chloroethyl. Ethyl. 1 nitrosourea. 1 nitrosourea. Now you can see it B. The abbreviation for carmustine is Bi. Then C for chlorine. And N for nitrosoureas. Nitrosoureas. Bi, C and U is that. Now it is chloroethyl nitrosourea derivative. So this is chloroethyl nitrosourea. Oh, now it is lipid soluble. It is lipid soluble. These drugs are lipid soluble. They can cross blood-brain barrier. Blood-brain barrier. So they can be used in treatment of brain tumor. Brain tumor. That's why used brain tumor as well as meningitis or meninges. It is used. Because of lipophilicity, they have cumulative effect. Cumulative effect. They have severe cumulative depressive effects on the brain. On the brain. That starts from 3 to 6 weeks after initiation of treatment. 3 to 6 weeks of initiation of treatment, you get depression. So, and moreover, it is cumulative. Whenever a drug is having more lipid soluble nature, it starts accumulating in our body. It starts accumulating in our body. So this is a nitrosoureas. Next. How does this act? Now, nitrosoureas are unstable compound. They're unstable compound. So decomposes spontaneously in body fluids to release alkylating agents. So how does that? You say in the body water will be there. Water. It can dissociate hydroxyl group. So now you start the reaction mechanism of activation from here. This hydroxyl group will pick the urea's nitrogen. Hydrogen of one of its nitrogen. When it picks, now what happened? This will be converted to double bond. Will be picked, is converted to double bond. Then this bond is broken. Broken. Now you see Cl, CH2, CH2, Cl, CH2, CH2. When it is broken, now what happens? This comes here. So double bond NOH. NOH is formed. Now, what is the compound formed here? It is called as isocyanate. Isocyanate. This is alkylating agent. Isocyanate you can also call, or carbamylating, or you can also call as carbamyl agent. And this group carbamylating agents, both are formed. Now this compound, so nitro group is double bond is released as NO2, is released as NN2. NO2 not N2. And OH is released again. So it is a catalyst like it is released OH. Now it is Cl. There must be one more, sorry. Then positive, you get positive. So this is. So here I will change and upload, please. You will get positive. Now this is the alkylating agents. This is the alkylating agent. CH2, CH2. Yeah, this is the alkylating agent. Now this alkylating agent will react with DNA and form alkylation. It forms alkylation. You can see it. It binds to another strand. On one strand and other strand it is binding. Now the formed isocyanate will also react with amino acid sequence, that is lysine, amino acid sequence lysine. So this also it blocks the metabolism of what is it? Basic amino acids. Basic amino acid. Because of this, because of two mechanisms, excuse me, these drugs acting against cancer. So these are the small changes. Small changes, not big mistakes. Sorry. This I will change and upload, please. This is. Any doubt here, please?
No.
Oh, I'm getting bulging acidity problem. Then alkyl sulfones. Alkyl sulfones. This is busulfan. This is busulfan. You can see the drug name and everything. Please check. Any doubt, please? Busulfan. You can see it is 1, 2, 3, 4. So 1,4-butane diol, butane, 4 carbon atoms of butane, diol, butane, diol, dimethyl. This is one methyl, this is another methyl, sulfonate, sulfonate. So this is the chemical name for busulfan. Busulfan is example for alkyl sulfonates. Now, This sulfonate group. This sulfonate group is a good leaving group. Sulfonate group is good leaving group. Act as a chlorine, similar like chlorine in nitrogen mustard. Sulfonate group is acting as a like chlorine. It is acting. Chlorine is also good leaving group. That's why we are using chlorine, not other halogens. Then mechanism, SN2 mechanism does not involve intermediate like aziridium ion. It does not form aziridium ion. So there is no formation of aziridium ring in Busulfan. Now it alkylates N7 position of guanidine. N7 position of guanidine. How does it happens? You see, nitrogen lone pair. Now you see here, this is electronegative. This sulfur is an electronegative atom. This is also electronegative. This is electronegative. This is electronegative. So this carbon is positive. Even this. The first carbon and fourth carbon are positive in nature. So this lone pair of electrons will attach to the will attract the first or fourth carbon. So, and we learned that the sulfonate group is good leaving groups. Sulfonate group is a good leaving group. So it leaves. So there is formation of bond here. So 1, 2, 3, 4. So again, butyl group is present. 1, 2, 3, 4. One sulfonate group is gone. Then in another side, from other side, other sulfate group is removed, is left. It binds to another DNA strand. So like this. Alkyl groups are attached. So what are these? Alkyl groups. So these are called as alkylating agents. But what is the difference here? Sulfonate groups are present. Instead of nitrogen mustard, nitrogen, here we are having sulfonate groups. This is Busulfan. Now, how do we synthesize? These are simple molecule, so that's why we are learning all this. Methane sulfonic acid. How many molecules we require? 2 methane sulfonic acid is required. This will react with butane diol. Butane diol. So when it reacts, know what happened? You get Busulfan. You get Busulfan. Now you can see its uses. It is used to treat chronic granulocytic leukemia. In leukemias, blood cancer, it is used. It is used. Then again, it is used before bone marrow transplantation to destroy the bone marrow and cancer cell. So suppose if this is bone marrow, you give this drug Busulfan to the bone marrow. So all the cancer cell, whatever is present, will die. Then clean that. Then you add new transplanted material, bone marrow. So it is, that's why it is used to prepare bone marrow transplantation. Bone marrow transplantation process. Only one drug, alkyl sulfones, Busulfan. Now, one more, last. We are coming to closure. Aziridine rings. Aziridines. Previous drugs, what happened? We were generating aziridine structure in the molecule. Aziridine was forming. Now we are taking directly aziridine rings. What is the name of drug? Thiotepa. Thio. This is thio. Tepa. What do you mean by tepa? You see here. Thio. N N N. So 3 N's are there. 1, 2, 3. Triethyl. You see triethyl. 1, 2. Ethyl group. This is ethyl group. This is also ethyl group. This is also ethyl group. How many? Triethyl. And where is this triethyl group attached to the nitrogen? You consider this is N1. This is N dash. Or this is N dash 2. This you consider N, simple N. Or you can write N1, N2, N3 also. Triethylene phosphoramide. Phosphoramide. So we are writing amide, but at the first itself we told that instead of oxygen we have thio group. That's why we are writing phosphoramide group. Do you understand this? Any doubt here regarding the structure? Carol. Someone is asking. Please go ahead.
Saying no doubts.
No doubt. Okay. This is the name for thiotepa. Now, see here, thiotepa is most active at low pH. Then it is used in carcinoma of breast, ovary, and malignant lymphomas. Let us see how it acts. So, see thiotepa, you can see it and you can observe the mechanism. Activation at physiological pH, they convert to active form. Now this active form, what happens is that you see thiotepa, now it can bind to guanine, one strand. Another active one. You can see it one more third ring is as such. Then this is how it gets activated. Then oxidative desulfonation also can occur. Oxidative desulfonation is occurring. So this is thiotepa. Tetraethyl phosphoramide. This is tetraethyl phosphoramide. This is toxic metabolite. Or you can also see here. It can dissociate one aziridine nucleus. There are 3 aziridine. There are 2 types of mechanisms. Sorry, I told up to here. This is another. Let me clear. I'm rushing, I think. So 3 aziridine nucleus are present. Now one bond after activation, it gets attached to the guanine N7. Among all the base pairs, N7 of guanine is more basic. So they will bind to the guanine N7 fastly. it binds to the N7 very fast. At the same time, it binds to another strand guanine. So, like this, it forms it. Another way is that you see thiotepa with the loss of water molecule. Whenever it comes in contact with water, there is release of aziridine. Now, this aziridine molecule can bind to the DNA. So now it causes breakdown of this ring, mismatching, everything it occurs. So this is the activation of aziridine nucleases, aziridine derivatives. What is the drug? Thiotepa. Thio NNN triethyl phosphoramide is called thiotepa. Then last, triazines. Triazines. This is the mechanism of activation. Dacarbazine, triazines is oh. Now you can read by yourself this mechanism of activation. It is also prodrug. It is also prodrug. On activation, you get methyl diazonium ion. Methyl diazonium ion. This is methyl from this portion you get it. Now you get simple alkyl groups. Here also there is no aziridine ring formation. Two drugs, there is no aziridine formation. One is this, one more. What is the drug? Oh my God. Busulfone. Busulfone. These two drugs will not form aziridine nucleus. In busulfone, the sulfonate group is good leaving group, so it leaves. In triazine molecule, you will get methyl group, methyl cation. This will bind to the that guanine residue. Guanine residue. Now, then nowadays they are using platinum compounds. Platinum compounds. It is also alkylating agents. Platinum compounds. Cisplatin. Cisplatin. There are many drugs, platinum derivatives. You see carbaplastin, then JM216, then oxaliplatin, picloplatin. All these are cisplatin analogs. Cisplatin analogs. Platinum compounds. Platinum is the what is that? Richest metal, costliest metal. Sorry, not richest. It is the price of platinum is very costly. You can consider the price of this platinum compounds 8,000 USD per dose. Like that, I heard last time when I was searching for class. No, I listened I read 8,000 USD per one dose. Rich people only can give. In India, there are some programs which they donate some medicines to the poor people. Government itself will donate. I hope in Kenya also there are some programs which they donate. 8,000 common people, even we can't. We are little middle class people. Middle class people. We only cannot take 8,000 USD. Oh my God. That is the cost of these drugs. Now, neutral inactive molecule act as prodrug. This is a prodrug molecule. Neutral molecule active. Platinum covalently linked. Covalently linked to chloro substituents. It is covalently linked. And amine molecules act as a ligands. This is like complex. Like complex. This is metal. Now these amine molecules is like ligand, organic molecules. Organic molecules. Now, activation in the body. You see, what happens is that one of its chlorine molecule will be removed and you are attaching with water molecule. We are attaching with water. Total water molecule is attached. Water molecule you are getting. Now, one more chlorine molecule will be removed and OH is attached. Now, this is the active molecule. Active molecule, which is binding to the DNA, It binds to 2 DNA strands. Now, that's what we are telling. Chlorine substituents are replaced with neutral water ligands. Produces positively charged species. Positive charged species. Why? Because oxygen lone pair of electrons gone. Lone pair of electrons are gone. That's why we are getting positive. Here positive, here positive, 2 positive. That's why it is 2 positive we are showing. Now these positive ions can react with DNA. Will react with DNA to form complex. So these drugs, this cisplatin drug, is good for solid tumors. Solid tumors. It is given by IV hydration. IV route of administration it can be given. The side effects you see: nephrotoxicity, kidney ototoxicity. Both these reasons are cumulative and irreversible. Sorry, for ototoxicity, this is applicable. Let me correct. For ototoxicity, it is cumulative and irreversible, whereas nephrotoxicity, cumulative and reversible in nature. So if you stop using, you get kidney damage will be reversed. It can be reversed. Then these are cisplatin derivatives, carboplastin, less side effects. These are second generation drugs. There are textbooks itself on cisplatin. One of my colleague has written on platinum compounds. Second generation, same activity as cisplatin. What is the advantage is this: less renal, GIT toxic than cisplatin. All these drugs. Dose limiting toxicity is myelosuppression. Then this is JSM 216, first orally active platinum compound. Orally active compound. Then oxalic protein, oxalic acid, platin. Then piclopatin. Piclopatin. Picoline. This is picoline moiety. So picloplatin. So these are the other derivatives of platin derivatives. Now this is only becoming big. If you want the details, you can study. 2 classes almost we have taken for this alkylating agents. Alkylating agents. Then side effects of the treatment, you see, it is for all the drugs, it is side effects. You see, skin, alopecia. Alopecia, you get loss of hairs, darkening of nails. Darkening of nails occurs, notably in 5-fluorouraceals. We didn't study it, but you can take this example. Then hematological side effects, anemia, leukopenia, thrombocytopenia. Thrombocytopenia. All these are growing cells. Active process is occurring in this hematological department in our body. So that will be affected. GIT, nausea, vomiting, microcystis, GIT infections, impaired GIT motility. All drugs will cause this GIT infections. You lose your appetite. You lose your appetite. Then endocrine, infertility. If you are a young woman suffering from cancer, what happens? You can't survive and you can't give birth. Infertility. Amenorrhea, absence of menstrual cycle. If present, irregular. Then neurological, peripheral nephropathy. You get burning sensation on the skin total, like that is called as peripheral nephropathy. Loss of interest, confusion, problems with thinking. So neurological, no, we go on thinking. You people think that suppose if I'm cancer patient, I'm unnecessarily holding my son or my daughter for their progress, like that. Thinking, it will kill them. Miscellaneous, impaired immune function, hearing loss, abnormal liver function. So all these are the side effects of our anti-cancer drugs. Some of the toxicity particular to the drugs are, you see, ototoxicity to platinum compounds. We didn't tell nephrotoxicity because it is reversible. Secondary tumors, alkylating agents, anthracyclines, you get cardiac toxicity. We didn't learn about these, but these are the side effects, in total side effects for all the cancer drugs. Anthracyclines, you get cardiac toxicity. Bleomycin, you get pulmonary toxicity. Doxorubicin, you get extravasation of injury. Extravasation means what happened? Suppose if they give this drug to this IV route, the drug will eat the flesh, only bones will be appearing. That is extravasation injury. You're getting it? This doxorubicin is given by IV route. So you will think this is now, and if you apply here, after some time, not after some time, after 2-3 doses or something, all the flesh will be gone. You can see your, what is that, ulna radius ulna. You can see that them radius ulna. Then bladder toxicity, cyclophosphamide, that is because of acrolein. Nephrotoxicity, platinum compounds. Then all these will cause tumor lysis syndrome. Lysis syndrome. These are the side effects. Okay. Side effects. Any doubt, please? Hmm. Okay. We'll stop here. We can meet next class. Let us take anti-metabolites. Now, we will just give introduction. Then we will stop this one. So otherwise, no, this will carry for further another class. So just we will study 1-2 slides, introduction for anti-metabolites. Then we will stop. Anyhow, we are having 4:50. 20 minutes is there. 10 minutes I will close. Please, you will be very tired. I know. Don't go. Anti-metabolites. Anti-metabolites is a broad term and could potentially refers to any drug that interferes with metabolic pathways You see, anti-metabolite, we are blocking the metabolism. Anti-metabolites, so it's a broad term that could potentially refers to any drug that interferes with metabolic pathways. Metabolic pathways means folic acid metabolism, adenine metabolism, purines metabolism, pyrimidines metabolism, that metabolism. So these are important metabolic pathways for the production of DNA and RNA. If that is halted, there is no formation of DNA. If there is no DNA, no replication means no transcription, no translation. So cancer cell will die. And prevent formation. That's what I was telling. You see, prevent formation of DNA and RNA. DNA and RNA. Now, the same thing. Antimetabolite is a chemical that inhibits use of metabolites. Metabolites are often, see, what is the important character of these antimetabolites? They have similar structure to that of our metabolites. So folic acid, for example, one drug is there, methotrexate. It has the structure similar to that of folic acid. Mercaptopurine is there. It has the structure similar to purine. Like last time we have seen ergmustrin, uracil mustard. Uracil mustard. The structure is similar to our metabolite. Are you getting it? Same way like that. So anti-metabolites have similar structure to the molecules the molecules the body uses in nucleic acid synthesis. So because of similarity, like sulfonamides, PABA and our sulfonamides have similar structure. So bacteria consumes sulfonamides instead of PABA. Same way here, they consume anti-metabolites. Instead of cancer, instead of what is it? Food material. So when they enter, what happens? So the antimetabolites, now after entering, what they do? Antimetabolites interferes with the normal cell function. normal function. How does this interfering occurs? It's a competitive inhibition. It's a competitive inhibition. And in the body, which part of the process it acts? It acts mostly in the S phase of the cell growth. We have seen the cell cycle. G0 phase, G1, then S phase, then G2 phase, M phase, if you can recollect. The S phase is called as synthesis phase. S means synthesis. What is the synthesis? It is a DNA. S phase. So these drugs will act at the S phase. Antimetabolites induce cell death during S phase of the cell growth by incorporating into RNA and DNA or by inhibiting enzymes. So directly they can block DNA and RNA or by inhibiting enzymes needed for nucleic acid production. They are needed for nucleic acid production. Then please do not go, please join. Now, antimetabolites can have toxic effects on cells such as halting cell growth, cell division. So these compounds are used as chemotherapy for cancer. Antimetabolites are toxic effects on cells. On cells such as halting cell growth and cell division. So they are toxic. They halt cell growth and cell division. So these compounds are used as chemotherapy for cancers. All these are properties of antimetabolites. They block the cell growth and cell division. These agents are used for variety of cancer therapies. Including leukemia, breast cancer, pancreatic, ovarian, gastrointestinal cancers. Gastrointestinal cancers. So this is what is the main important property? Antimetabolites have similar structure with that of natural metabolites. So they get incorporated into our metabolic process, inhibit DNA, RNA, or the enzymes necessary for the production of these nucleic acids or nucleic bases. So they block cell division or cell growth. How they block? Competitive inhibition. In what phase of the cell cycle they act? They act at the S phase. S phase, because S phase is the synthetic phase. It is actively involved. The cell is actively involved in the synthesis of DNA. Then it is used in variety of cancers. Please mute yourself. This is what we were telling. I think you remember this structure, this figure in the first week. I have told this. Our drugs will act at DNA synthesis. S phase. You can see it. What are the examples? Antimetabolites. Examples is folic acid analogs, methotrexate. Purine analogs. See examples. Pyrimidine analogs, miscellaneous hydroxyureas. So these drugs we are going to learn. In simple, you can see classification. Folic acid analogs, methotrexate. The one which is exposed in bracket in a box type is most widely used, methotrexate. Pralatrexate, pemetrexate, trexated. All these are folic acid analogs. Then purine analogs. Purine analogs. Mercaptoguanine. Mercaptopurine, you can also call. Thioguanine. Thioguanine. Pyrimidine analog. Fluorouracil. Fluoxyridine. Trifluridine. Cytarabine. Gemcitabine. Gemcitabine. All these are pyrimidine analogs. Pyrimidine analogs. Now, you can see it, how these antimetabolites, it can block either folic acid, it can block either purines or pyrimidines. When you block, here all these combined, folic acid, purines, pyrimidine, combined together form nucleosides. Nucleosides are combined to form nucleotide by acid, by sugar, phosphate. Then you get DNA. From DNA, you get RNA, you get proteins, then enzymes. If one is blocked, if there is no folic acid, there is no nucleosides. There is no formation of purines and pyrimidines. Purines and pyrimidines. If this is automatically, all the sequence will be halted. All the sequence will be halted. So this is the importance of these drugs. The drugs. So let us see. We can learn, as I told you, 10 minutes. So it's 5 o'clock. I'm going to stop. Remaining. Next week we can finish. Next week, not next class, we can finish this anti-metabolites. So students, any doubt? Any doubt, please?
No.
Excuse me, sir.
Please, madam.
As a class, we have a suggestion that we do the quiz on week 6.
No issue, no problem. Make sure if you do on week 6, there will be issues of payment. So think of yourself. Week 5 or week payment, suddenly they block your blackboard. So think over that and tell me. No issue for me. If you all really agree, we can do it. Okay then. Bye. Bye bye.